Okay, now these lessons are a recap or sort of support to Axel's wonderful presentation. Okay, so I'm looking at plotting and usage of linspace. Now, let's go through this code to get it one by one. Now, the linspace, let me reduce this. Okay, so the linspace just generates vectors. It creates vectors, right? So its first argument, it takes three arguments. Okay, its first argument, where the 0 is the first digit you want to put into your array or matrix. Let's say your row vector. Okay, so for instance, let's come down here. You want to start with something like 0. Okay, then we want to our last number to be what? 2 pi. So it's going to go like 0 plus 1 plus 2 plus plus 1 plus 1 plus 1 up to what? 2 pi. That's the default function. But if you had put something like 2 here, okay, if you had put something like 2, then you come here to put perhaps 9. Okay, you give linspace this argument. Then what is linspace going to do? Linspace is going to move from 0 plus 2 plus 2 plus 2 plus 2. When it reaches 9, it stops, which implies when it reaches let's say 8, it will stop, because 9 is not part of the multiples of 2. You are getting it. All right, now let's come back to the code. Now x equals to linspace 0 2 times pi. It's not anything dangerous. It's just what you want to assign the values linspace is going to create into x. So x is going to have 0 plus 1 plus 1 till it reaches 2 times pi. It stops. Now 2 times pi is just a predefined constant. Okay, you know the value of pi is just a predefined constant in MATLAB. Let's go to the second line. Y is equal to sine x. You know this as mathematicians. So you find the sign of x and assign it to y. So now you have your x values and y values set. Therefore, we can plot. How do we plot? We call the plot function. Anytime you type a function's name followed by parentheses and you give it an argument or not, you've called the function. That is it. So we've called the function plot. It is coming to execute. It's coming to do its work and leave. Now, when you call plot, your first argument, which is where the x is, this is what you call your first argument. X is your first argument, right? And y is your second argument. You get it? Let's look at the linspace function. 0 was your first argument and 2 times pi was your second. So arguments are just the input a function receives. Let's look at the x label. It receives a string, right? Because it's in quotes. So x is a string like that. Fine. Let's continue. Now, after plotting your x and y, your x label function just labels the x with a string, and your y label function just labels the y with a string. So the x label and the y label things that are there, take them as sentences. Take string as sentences. Okay, group of letters, numbers, and characters. Take them as sentences. The same applies to the title. They are not something you can calculate. You cannot do workings with strings. Okay, unless some special cases, but under normal circumstances, we don't calculate with strings. Now, hold on. Is just used if you want to plot a second graph on your first graph. So you hold on to the first graph. Let's plot a second graph. But before the hold on, let's run the first graph. So let's copy the hold on code and let's cut it out. So let's run the first one. These are just the workings of MATLAB. Forget about that one. We have slow connection here. It's running. So okay, all right. So that's what the legend there. Okay, so the legend, comma, instead of data 1, you could have put what you want there. And instead of data 2, you could have put what you want there. Now you see the green lines up there. Don't worry, they were trial works I was doing already. Okay. So take note of, you see the infamous sine function, right? You see its shape. So we've just plotted a function of what? The sine function, y equals to sine of x. Now, let's go back. Let's hold on to this graph and plot another. So forget about the green line you see over there. Okay, they were just trial works I was doing. The actual plot you've just plotted is only one, sine function. You're okay with that? Now, let's go back to our code. we are here. We want to add another plot to our pre-existing plot, right? I have the codes already, so in order not to waste time, let me just paste and explain. Let's go through these codes. Now, hold on. You know what it does? It holds on. Let the first plot hold on. Then let's plot the second. This time around, we declared we want our x to be 1, 2, 3. Let's make it 4, so it will be distinct from the trial works I was doing. Let's make it 4, and let's make this let's say this to 4. Don't worry, I know you understand x equals to 1, 2, 3, 4. You understand what they are. They are just row vectors. That is it. Okay, now we want to plot the new values of x and y, right? I want to give them, what is this j s dash dash doing? J stands for green. Okay, so that's slot. You can take your note and be writing something now. J stands for green. The S stands for square markers. Square markers. Markers are what you use to indicate your coordinates. Okay. Usually under normal circumstances, in GHS and the rest, you use asterisks to indicate our coordinates. Right here, we want to use square markers. Let's try to use asterisks here. Let's try to use asterisks here so you see what you are talking about. Asterisks. Let's make our line black. Okay, the symbol for black is K, remember that. And we don't want our line to be dashed as the trial work I was doing, so we'll just single dash. Okay, let's continue. The line width is just the width of your line, as the name implies. Okay, so our line width, we've set it to 4. It's up to you to just be taking notes, okay, and be noting the syntax of this. Right now, where it has gotten to is just true and poor. You already know what's going on, so just notice the pattern and insert. Marker size 10. What does that mean? The size of the marker in this particular example, our marker is what? Asterisk. Then legend, we put anything there. Okay, so let's run this and see what we will get. Okay, so we have that. Okay, as expected. So black line, asterisk, exactly, marker size and the rest. So that is how to plot. Okay, so let's go over this code again. So x equals to linspace. You are creating what? A row vector, and you are assigning it into x. You are storing the values into x. First number is 0, then last number is 2 times pi. Now your y is equals to your sine of x. Sine is a predefined function, so MATLAB will do that for you. Plot x and y. Remember, your first coordinate or your first argument for the plot is what? Your x vectors or values. Then your next is your y, just as in your normal mathematics. X label, y label, title. I'll not talk about that. I know you are good with that. You hold on to your first plot, then you plot the second. Right now, x is equals to what? 1, 2, 3, 4. You are declaring your new points to be plotted, right? And you come here. We could have made this scale. Let's say you want to make a blue line. Depends on what they tell you. I think I'm having difficulty moving this. Let's say we want a blue line. We want our markers to be probably, let's say, circle markers, right? And line width, let's say the line should be, you want the line to be very thin. Let's make the line width 1. Then the marker size what? Let's say 3. Now let's run that. The legend is anything for now, but given to you according to the question, you know what to do. Okay, so there's a new input. It is on what? Where is the blue? Okay, because they are the same coordinates. Okay, let me change something here. Let's make x. Okay, let's make x times 2. Let's do this. R equals x times 2. We are just shifting the vectors. Okay, and t equals what? Y times what? Times 2. We could have even do them, you don't know, let's do them times. Now let's plot r and what? T. So we have r here and we have what? and we have T over here. Let's make the color red. Let's make it red. So this vector has a new position now, and let's try to plot this. So it's just about you experimenting, okay, with your various T is supposed to be equal to, which means you're assigning. All right, so let's run that. Let's see our outcome. Okay, so our new vector has been what? Shifted. You get it? Because you multiplied by a scalar, okay, so it has just been expanded, or how do I say it, diminished or magnified. Okay, it is at the same position but diminished or magnified. So that is all about it. It's up to you to practice. Let's move on to other videos.